So we have a rectangular patch of ground, triangle SGH, where SH is 58 meters, GH is 30 meters, and GHS is 68 meters, or 68 degrees. Sorry, the last one's the degrees. The circle is the helicopter pad. It is the incircle. Incircle means that all three sides are tangents. They only touch the circle once. Okay, so find SG, give your answer in meters. So S to G. So what's this side here? We call it X. This is a standard cosine rule. You can't use Pythagoras' theorem because it's no indication that it's a 90-degree triangle. You can't use SOHCAHTOA because of, once again, no indication that's a right angle triangle. Can't use the sine rule because you only can't use the sine rule because, well, basically you'd be lacking one of the other angles. You'd have x over sine 68, and then you'd have a or 30 over sine a, and you'd be missing two of the variables. You don't have x or a, so that's a bad choice. So this leaves the cosine rule, which is a squared equals b squared plus c squared minus 2bc cos a. We're going to let a be 68 degrees. Okay, and that means that small a will be represented by x. Okay, so it's going to be turned into x squared equals 30 squared plus 58 squared minus 2 times 30 times 58 cos 68. Go to your calculator, make sure it's not in radians mode, make sure it's in degrees mode with d on top. You're just going to get 30 squared plus 58 squared minus 2 times 30 times 58, and it's going to be cos 68. And you're going to get 2960.37. 60.37. Square root your answer, and you get 54.4. So that is your first question done, and look at how many marks it goes for. Always worth knowing. And sec here. So that goes for 10 marks out of 55, so it's a good one to start off with. Find the angle HSG. HSG will be this angle here. We call it A. Okay, and now we know what length this one is. This one here is 54.4. We can actually try and use the sine rule now. So if I grab this full, I can grab the full thing here, and that's the angle I'm looking for, is this A on the top right, which is S. Yeah, this angle A here is the same as this one down here. Okay, and what we're going to look at here is the following. We're going to use the sine rule. So you're going to use A over sine A, so it's going to be 30 over sine A, and then pick 54.4 opposite the 68. Oh, sine 68, that is. Now, you can cross multiply up to sine A, so it's 54.4 sine A equals 30 sine 68. And bring the 54.4 underneath, so it's going to be sine A equals 30 sine 68 over 54.4. Okay, and then what do we get here? We're going to do 30 sine 68 all over 54.4. And we get this, syntax error. Forgot to close the bracket, I believe. 0.511. Now we just have to find out what the angle is, sine A. And sine A is shift sine inverse 0.511, and you get 30.73. Now, apparently if we don't round this off, we keep this a bit bigger. So 30 sine. So see the way I got a shift sine inverse 0.511, and see the way I got 30.73. Now, I'm just wondering what happens if I just sine inverse the full thing and don't do any rounding. So shift sine inverse 30 sine 68 all over 54.4. Close it out there. And you can see that I get 30.75 more accurately. So there is a bit of skill in maybe not rounding off too easy there. I only identified that because of the marking scheme, to be honest. Be pretty harsh. Now, let's go. So that's also worth, that was worth 10 marks as well. So that's 20 out of 55. Now we're on to part C. Find the area of the triangle SGH. Now, SGH, we were just on a second ago, have a diagram of it here. Okay. And we know that this angle now is, we know that this angle here is, what's it? We just got it a second ago. It's 30.75. Now, to get the angle, and we also, you can pick any two sides and the angle in between you want. I'm going to pick the 30 and the 58 and the 68 in the middle. Believe it or not, you could have done this at the start of the question. 30, 58, 68 degrees. There's no reason why you can't do this. So it's a half AB sine C, 30, 58, 68. And by using these numbers, you're not risking any mistakes from any other part of the question you might have done. Okay. And you put that into your calculator. I have 30 by 58 by 68, and you're going to get 806.65 meters squared. So what's it? Half 30 by 58 sine 68. Yeah. Now, D part 1. Find the area of HSP in terms of R, where R is the radius of the helicopter path. HSP. Now I'm going to need the diagram back over here. So just going to get rid of all these for a minute. HSP. So it's going to take a picture of this. Make it smaller, obviously. Now this is the part D is the first part where you should probably feel challenged. The rest of the parts weren't too different on ordinary level, if I'm being honest. So you've already passed the question, so to speak. It's just whether or not you can get any more attempt marks to get yourself into the honors part, the honors results, as in at the H5, H4 results. Okay, so we're talking about this triangle here. Now, find the area of HSP. So we're trying to find the area of the full thing. Okay. It turns out this is only a 5 marker because it's actually you can see the right angle here, and it's a half base times height is the area of a triangle, and it's just going to be a half. It's going to be a half 50. It's going to be a half 58 times R, which is quite simply going to be 29R. Now it's looking for SGH, and SGH is the full triangle. Okay, so what I'm thinking is I might use a similar trick to what we just did a second ago. So is everybody see this one up here? I can use that as r because r is the radius. And we found the length of GS. I'm pretty sure we found the length of GS earlier, did we not? Or SG. It's 54.4. So I can use, so for this green triangle, we already know the size of the purple triangle is 29r. But for the green triangle, I can use a half base times height, which is 54.4 times r. Now, I won't have got this question other than I've done one similar to it before. And what we're going to get is 27.2 r. And what that leaves over is the blue triangle. And in the blue triangle, it's going to be a half 30 times r. Which is 15r. Then we're going to add all three of them together. We're going to add 29r plus 27.2r plus 15r. And long behold, we're going to get 71.2r. Find the value of r. Give your answer in meters correct. Next one. So did we find the area of the full triangle yet? We did. 806.65 meters. So the full triangle is 806.65 meters squared. And we now know that it equals 71.2 r. R is going to be 806.65 divided by 71.2. So 806.65 divided by 71.2. And it's going to be 11.3. Once again, always check your answers before you move on. And that is in fact 11.3. That's another 5 marker. Okay, now we're on to what I hope is the end of the exam. Part E. ST is a vertical pole at the point S. The angle of elevation of the top of the pole from the point P is 14 degrees. So that's 14 degrees. And once again, remember, we're only allowed to work with 2D triangles. Okay, so everything we're doing is going to be 2 dimensions. So that'll be T, that's S, and that's P, and that's 14 degrees. Okay, find the height of the pole. The goal of the question is to find out what this green part right here is. Okay, now, in order to do that, I'm probably going to need to know one of the other sides. And P to S looks like the most reasonable assumption, because P to S is very much on my original diagram. What we're going to do is we're going to go back to the beginning and remember the angle HSG. HSG was 30.75, okay? So that brings me to this diagram here. So this whole angle is 30.75. Now, what you don't realize about incircles is that in the incircle, every angle is bisected. So you get your 30.75 and you divide it by 2. And what you get is 15.375. So what I know straight away is that this angle here is 15.375, okay? Now if I grab this diagram here, okay, I'm just going to bring it to the current page, okay? I'm just going to grab this triangle here and cut it. Now, you probably saw me over here a minute ago looking at this diagram here. And what I was trying to do is trying to figure out what P to S is, okay? So if I paste this here, you can see that P to S is this green line here. That's what P to S is. And we know what R is because R is the radius and R is going to be 11.3. Okay, and what we have is a right angle triangle where we know that one of the lengths is 11.3. We know that this angle is 15.375 We're after PS, which is the hypotenuse. So we'll just call it H. Now, it's a right angle triangle. I can use Pythagoras' theorem or SOHCAHTOA. I'm going to use Pythagoras' theorem, so I'm going to use SOHCAHTOA. So I have the opposite and the hypotenuse. So I'm going to use sine 15.375 equals 11.3 divided by H. H in turn, H is going to division on the right, multiplication on the left. This sine 15.573 would be multiplication on the right, which makes it division on the left. I'm going to put all that into the calculator and see what happens. So 11.3 divided by sine 15.375, 42.62. So H is 42.62. So H is in fact PS, so that's 42.62. Our goal is to find out what H is. So now we're going to use another triangle. Okay, just going to get rid of all these workings from earlier. We're going to use we're going to use that right angle triangle on the top right of the screen. Now we have the opposite 14 is H, which is the height of the pole, not to be confused with the capital H I used earlier. And the adjacent is going to be 42.62, so it's going to be tan 14 degrees equals H over 42.62. Transfer the 42.62, which is division on the right, becomes multiplication on the left. And what we're going to get is 42.62 tan 14, 10.62 or 10.63. Reread the question. Does it want it correct to one decimal place? And H is 10.6. Check your answer. Oh, sorry, I read that wrong. Oh, 10.63, so H is 10.6. In the marking scheme, it has it as 10.7 meters, and that could be a round off, like something so small like a round off of the last one could have caused that to happen. Trying to see now, 42.6197. I think we're good with that. Actually, I'm in favor of my answer over there, so all good. Okay, and that's us, guys.